How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for drawing Lewis structures. Number 1, draw the Lewis structure for N2H2, including any unshared electrons. So first thing we need to do is figure out how many valence electrons there are. So nitrogen, I see, is in group 15. So each nitrogen has 5 valence electrons. Hydrogen, group 1, each one of them has 1. So nitrogen, well, I got 2 of them, each with 5, so I have 10 valence electrons from those 2 nitrogen. Hydrogen, same kind of process, there's 2 of them, each of them only has 1, so I have 2 from hydrogen, which gives me a total of 12 valence electrons. So the way this is going to work out is I'm going to do nitrogen bonded to nitrogen, and each one of those nitrogens is going to have a hydrogen bonded to it. So I can see now I've placed a total of 2, 4, 6 valence electrons, and I got to finish the octets. Well, hydrogen is an exception to the octet. It's happy with just that one bond. So now I have a total of 6 more valence electrons to place. So best way to do it symmetrically would look kind of like this, and hopefully you're looking at that and go, that's kind of a weird thing, right? So I know unpaired electrons, not so good. I know nitrogen has 5 valence electrons. It's probably looking to make 3 bonds. It's only made 2. So I'm going to add a multiple bond there, and here I go. I got my Lewis structure for N2H2. Right, number 2, how many valence electrons are there in the Lewis structure for CH3CH2Cl? So this one, we're not even getting the Lewis structure, it just wants to know how many valence electrons. Well, let's see, we got carbon, we got hydrogens, and we got chlorine. How many carbons do we have here? We got 2 of them. I know that each carbon has 4 valence electrons. So I have 8 valence electrons from carbon. Hydrogen, there are, let's see, there's 3 here, there's 2 there, so we got a total of 5 hydrogens, each with 1 valence electron, because it's in group 1. So I have 5 valence electrons from all the hydrogens. Chlorine, I only have 1 of them, and it's in group 17. So it has 7 valence electrons, which tells me when I add these together, I end up with a total of 20 valence electrons in this molecule. All right, number 3, draw the Lewis structure for the CO3- ion. So same process, we got carbon, we got oxygens. All right, there's 1 carbon with a 4 valence electrons, and we have 3 oxygens, each with 6. I have 18 from the oxygens, I got 22, but this -2 tells me that there are 2 more valence electrons, so I have a total of 24 valence electrons. So I put carbon in the middle, and I make a single bond with each of those oxygens. And then the next step is to complete the octet. Sorry, I'm just making room for myself. So there's 24 valence electrons. So finish the octet around all of the other non-central atoms. And when I do this, I've now placed all 24 electrons. Now the problem with that is I don't have an octet on this carbon. So the way I'm going to fix that is I'm going to take 2 electrons from one of the oxygens, and I'm going to use them to make a multiple bond. So now there's a double bond with one of those oxygens. Carbon's got an octet, everything's got an octet. And if I check out the formal charges for everything, this oxygen's going to have a formal charge of 0. This carbon has a formal charge of 0. Each oxygen has a -1 formal charge on at least those 2, which is where we end up with this -2 charge overall. So best Lewis structure like this. If you're asking, well, hey, why that oxygen, not the other ones? The answer is, there's resonance. That is a very good question. It doesn't have to be that oxygen. It could be either one of the 3. So that's how you know that there's going to be resonance there. All right, number 4, what is the formal charge on the nitrogen in this Lewis structure? So they give us the Lewis structure and they want us to figure out the formal charge. So the formal charge for nitrogen is going to be equal to the number of valence electrons. So there's 5 for nitrogen, right? It's in group 15. So there's 5 valence electrons minus how many electrons did it keep to itself? Well, from that drawing, there's none. It doesn't have any unshared electrons. And then half of the bonding electrons, which each one of these bonds has two electrons, and then this double bond has 4 electrons. So half of all of that is 4, right? So if I do the math, the formal charge on this nitrogen in this structure is a +1. There you go. Number 5, what is the formal charge on sulfur in the sulfate ion, SO4 2-, where the Lewis structure is as follows? So another one where they're giving us the Lewis structure, and they want to know, well, hey, what is the formal charge on that? So sulfur. If I take a look, sulfur is in group 16, which tells me that it has 6 valence electrons. Now we've got to subtract, well, how many electrons did it keep to itself? In this structure, none. It doesn't have any unshared electrons. And then what is half of all the bonding electrons? Well, if there's 1, 2, 3, 4, 5, 6 bonds total, there's 12 electrons, half of that is 6, right? So there's 6 electrons, which tells me that the formal charge on sulfur in this structure is 0. Number 6, draw the Lewis structure for ICl2+. So you go, all right, how many valence electrons do I have? I got 1 iodine, so I got 7 valence electrons from that. Chlorine, there are 2 of them, each with 7 because it's in group 17, so I get 14. Add those together, I got 21. This plus tells me that I lost 1 electron, so I got 20 valence electrons. So put iodine in the center, make the bonds with the chlorines, finish the octets around the non-central atom. And when I do that, I have placed 16 of my 20 valence electrons. All right, put any leftover electrons on the central atom. I have 4 left over. I have now placed all 20 of my valence electrons. Everything's got an octet. That looks pretty good, but I have to put these little brackets around because there is a +1 charge overall, and that's how we indicate that. So there you go. That's the Lewis structure for ICl2+. 7, what is the formal charge on chlorine and fluorine in the ClF molecule? So I go, all right, well, let me draw it. ClF. I know that they're both in group 17, so I have a total of 7 plus 7 valence electrons. I have 14 valence electrons. So now let me finish these octets. I may not really know which one I'm considering the central one, but let me finish these octets. And hey, once you know it, I have now placed all 14 of my valence electrons. So let me do the formal charge math for chlorine. It had 7 valence electrons. It kept 6 to itself, and it made 1 bond, so its formal charge is 0. Same process for fluorine. Fluorine had 7 valence electrons. It kept 6 to itself, and it made 1 bond, so its formal charge is also 0. There you go. That's it. Hope you found it helpful. See you in class. Goodbye.